Okay, our keywords today are converse, inverse, and contrapositives. So we're going to start with a conditional statement. We're going to start with the conditional statement. We're going to stick with the car example. If the car starts, then the battery is charged. That's a conditional statement. The hypothesis is the car starts. The conclusion is the battery is charged. So do you think that that's a true statement? If the car starts, then the battery is charged. Yes, that is a true statement. So let's write somewhere over here the fact that that is a true statement. And let me put an arrow. $400. Yep. Okay, so a true statement. So I'm going to put a little arrow showing that that is what we would consider as a true statement. So if the car starts, then the battery is charged. Now we can also use symbols to talk about our hypothesis and conclusion. They use the letter P and the letter Q. The letter P is for our hypothesis, the letter Q is for our conclusion. It's just symbols that they use. They could use if P, then Q as another way of saying if-then statement. They could just say if P happens, then Q has to happen. If your hypothesis happens, which is P, then your conclusion has to happen, which is Q. So if P, then Q. And then the last way to actually write it, which is a lot easier for us, is just to put a P and then an arrow and then a Q. That means the same thing as if P, then Q. So this is actually the easiest way for us to write our symbols, is just to put P and then an arrow and then Q. So that's just the symbols for a conditional statement. So when they say write a P to Q statement, that means you need to write an if-then statement. If something happens, then this must happen. So P to Q means if P, then Q. Now the converse of a statement is formed by interchanging the hypothesis and the conclusion. If you interchange them, that means if you flip the statement around, I wrote that in parentheses here. If you flip the statement around, you make the converse. So the converse is made when you flip it around, the first statement. That we're going to continue to use the battery in the car statement. So we're going to be using this statement all time in our notes, right? Up until the very last one. If the car starts, then the battery is charged. If you flip that around, you would put the battery is charged in the front, and you would put the car starts in the back. So it would look like this. If the battery is charged, then the car starts. That would be the converse of our original statement. The converse of our original statement would be if the battery is charged, then the car starts. You see how I just took the first part, put it in the back, and I took the back part and put it in the front. That was from our original statement. Yes, this is the converse of the original statement. Okay, so converse of the original statement right here. Now, is that a true statement? Is the converse of our original statement true? If the battery is charged, then the car starts. It's not necessarily true. Because what happens if the starter doesn't work? What happens if the fan belt's is broken or something? What happens if the alternator's not working or something? Then the car's not going to start just because the battery's charged. So that one is not necessarily a true statement. Not necessarily true. The symbols for converse, instead of P to Q, would be Q to P because you're flipping it around. So for our symbols, you would put Q to P instead of a P to Q statement. The converse would be a Q to P statement. All right, let's go to slide 2. Now we're going to talk about inverse. Remember our title was converse, inverse, and contrapositive. The inverse is when the hypothesis and conclusion are both negated. You get the inverse of the statement. Now, what does negated sound like? Sounds like negative to me, right? Negative or not. Sorry, did I say that weird? Negative. Negative or not. So negated means you put a negative sign in front of it or the word not in front of it. And in our reasoning section here in this chapter, the negative sign, when we talk about inverse, the negative sign is actually this little squiggly. So when you have our symbols for inverse, it's the little squiggly line P to the little squiggly line Q. We don't flip them around. We're still using P to Q, but we're putting the negatives in front. So we're changing them both into nots. If not P, then not Q, is basically what you'd be saying here. Those little squiggly line represents negative or not. It's either the negative, the word negative, or the word not. So if not P, then not Q is what you'd be saying here. So let's talk about the inverse of our original statement. Do you remember the original? If the car starts, then the battery is charged, right? So what would the negatives of those be? If the car does not start, then the battery is not charged. Right here, inverse of the original. If the car does not start, then the battery is not charged. If the car does not start, the battery is not charged. Is that true? If the car doesn't start, is it only because the battery? Oh, there's lots of reasons the car might not start. So again, not necessarily true. This statement is not necessarily true. Now, we know the conditional statement was true, but we found out that the inverse was not necessarily true and the converse was not necessarily true. Just because the conditional statement's true doesn't mean the inverse and the converse has to be true. So those we can see that they were definitely not necessary. Now, they might be true. If the car doesn't start, maybe the battery wasn't charged, but that's not the only reason the car won't start. But you have to know that if the car started, the battery had to have been charged. So that conditional statement had to have been true. Now, the third one of our keywords is called contrapositive. Now, contrapositive, before I show you what it is, let's use our inductive reasoning skills. Converse was flipping it around. Inverse was making them both negative. Contrapositive would be then what? Would be what? Positives would be the conditional statement. One positive, one negative? No. Contrapositive is when you do both. You flip it around and you make it negative. So interchange and negate both the hypothesis and the conclusion. And then let me add something here. In parentheses, you flip the statement and make it negative. So you have to do both. You basically combine the converse with the inverse and you get the contrapositive. You combine the two, you get the contrapositive. So let's think about what the contrapositive would be to our original statement. The original statement said if the car starts, then the battery's charged. The inverse was if the car does not start, the battery's not charged. If I flip around the inverse, do I get the contrapositive? Yeah, because we already made it negative here, so if you flip it around, you'll have the contrapositive. So what would I get if I flip this inverse around? If the battery's not charged, then the car will not start. Okay, so our contrapositive, the symbols are going to be the opposite of Q to the opposite of P. So you flipped it around and you made it negative. So you did both. You flipped it, Q to P, and you made them both negative. That's contrapositive. The contrapositive of the original was if the battery is not charged, then the car will not start. If the battery's not charged, the car will not start. Now, what do you think about that statement? If the battery's not charged, the car will not start. That is a true statement. If the battery doesn't have any charge in it, the car cannot start. That is a true statement because the original statement is true. Contrapositives will always be true if the conditional statement is also true. So that would be something you might want to underline. Contrapositives will always be true if the conditional statement is true. Contrapositives are always true if the conditional statement is true. All right, after contrapositives, we have one last slide. We want to talk about biconditional statements. Biconditional statement. When the conditional statement and its converse are both true, you combine them into a biconditional statement, which must contain the words if and only if. Let me underline that so we see those key words right there. If and only if. Let's take an example of this statement. Two perpendicular lines intersect to form a right angle. That's a fact. Only way that lines can be perpendicular is if they make a right angle. So that is a fact, true statement. If you look at the conditional statement that we could make from this example, if two lines are perpendicular, then they intersect to form a right angle. That's basically based from this example right here. If two lines are perpendicular, then they intersect to form a right angle. So that would be from this example, we made a conditional statement. We put an if and a then. So notice the if and then. Those have to be in there for it to be a conditional statement. So if two lines are perpendicular, then they intersect to form a right angle. Now, what would the converse of that be? If I flipped that around, if they what? Intersect to form a right angle, good, then they're perpendicular. That's your converse. If two lines intersect to form a right angle, then, oops, I forgot they, then they are perpendicular. If two lines intersect to form a right angle, then they are perpendicular. That would be my converse. Now, is the conditional statement true? If they're perpendicular, then they make a right angle? Yes. Is the converse true? If they intersect to form a right angle, then they're perpendicular. Yeah, they both are true statements. Since both of these are true, you can make a biconditional statement. You could put it together, take those two statements, put them together, and make it look like this. Two lines are perpendicular if and only if they intersect to form a right angle. You can put this phrase in the middle and it puts your converse and your conditional statement together into one. So you got biconditional statement. That means converse and inverse are both true. That means that's where the bi comes from. Two statements. Converse and conditional are both in there. Yeah. No, you don't have triconditionals. No, just biconditional statements. You can only have one phrase, if and only if, in there. So if they're both true, you can combine them into a two lines are perpendicular if and only if they intersect to form a right angle.